Good afternoon, everybody. Thank you. I would like to thank the Congress for inviting me to present today. And my presentation is going to be very different than the presentations we've had today. I'd like to apologize that it's in English because my Spanish is not very good. And I'm going to move very quickly and show many slides and not talk a lot of detail and not present a lot of detail on those slides, but happy to talk to you a bit more. So what I want to do is talk about technology and challenge you to think about technology in a different way and what it means to the future of mining. And I'm going to tell you why the future of mining really needs us to look at technology in a different way if we're going to survive and have mining as an industry that's sustainable and has a strong future because it's an essential industry. I'll quickly talk a little bit about what Mining3 is and then go into that. So Mining3 started in 1991 as what's called a cooperative research center in Australia. Cooperative research centers bring industry, equipment manufacturers, suppliers, researchers, and at the time the Australian government funding to look for how we solve problems of the future. So Mining3's objective is to work for the mining companies and the industry to find out and look at what the future will bring, what will be the ecosystem, what will mining have to solve in terms of challenges of where we'll be in the future, and to develop roadmaps of how we take the technology we have now and implement that to achieve those future roadmaps. What technology do we have to still develop and help mining companies go there in the future and understand how to create a new future in mining. So Mining3 in 2016, in 2014 we became completely industry funded. So at the moment we're completely funded by mining companies and equipment suppliers. And in 2016 Mining3 was created out of the joining of what was called CRC Mining and the mining capability within CSIRO, which is a big government industry or government research entity in the CSIRO, and all of the hard rock mining within CSIRO is now done as a joint activity between CRC Mining and CSIRO in a new thing called Mining3. And if you want to know what Mining3 means, I'm happy to talk to you about it over a beer this evening. Mining3 has members, so these companies fund Mining3. They provide about 10% of the funding to allow us to look at fundamental topics. So we look at how can we identify what the needs are for the industry, build these roadmaps. We help mining companies develop their own innovation frameworks and have them and work out how they get from where we are now to where we need to be in the future to achieve those challenges. So these are the people who are members of Mining3, but these were the companies that we worked with last year as in doing projects. So we have a wide engagement within the industry. We also work with many universities. Our core universities are those which we talk about over there, but we also work with many different institutions around the world, CSM in Colorado, Colorado School of Mines, Aachen University in Germany, PTB is a German testing agency, VTT in Finland. We have an office in Santiago, and we also have one in Toronto. We also have a number of major initiatives. One of the new ones is one called Transforming Cave Mining, which is a joint collaboration between Mining3 and the University of Queensland around what's called the Caving 2040 Initiative to generate the next generation of caving and to look at how caving transforms into a new horizon. So really, our Mining3 doesn't do anything unless the industry drives it, but the industry gives us the opportunity to look at how we solve those problems of the future, but how we deliver them into technologies of today. We don't believe the industry can transform itself quickly. It needs to transform itself by working on the technologies that we need in the future and applying them slowly and making the change management so we get to where we want to be in the future. So if I put a technology on a truck today that allows me to make a truck go faster or do something intelligent with the truck, it would be good to know that that's a technology that I'm going to need for a new future, and I can then start training people and having people understand and our organizations understand how we use that technology, how we build the building blocks to the future. And Mining3 has been doing this for a long time and working on how we do that. Since 1991, we've been working on what are the building blocks that will change what mining does. And I want you to think about the technologies that we've been talking about today, not as how do we apply those technologies to do what we do today, but how do we apply those technologies to do what we need to do in the future. Use those technologies to do what we can't do today, not what we can do today faster. So automating a bad process just means you have an automated bad process. What automation allows you to do is something completely different. The same with many of the sensors that we have today. And the other thing we've got to think about is we have lots and lots of sensors in mines today, and all of those sensors tell us about what the equipment is doing. They don't tell us about what the rock is about. So almost 99% of the sensors we use today and we digitize is about how trucks move, how shovels operate, the interactions. Very little of them tell us what's in the truck, what is the material itself. And the future of our world is being precise about how we deal with the material that's in front of us. And I'm going to go through a little scenario about why that's important. Quickly, Mining3 objective is to develop these technologies and to then put them out into the marketplace to get them commercial. These are some examples of some technologies that Mining3 has been involved in, from a cave tracker technology with Alexon through to the Dynacut hard rock cutting technology that Komatsu is developing. Some of you have seen SmartCap, which is our fatigue monitoring technology, brainwave detection technology. We have a technology in water jet drilling for gas production, oil, an alternative to fracking, how to create holes in rock very quickly using a water jet-based drilling technology. And so another one you might know of us is Mineware. Mining3 currently or recently sold Mineware to Komatsu about 2 years ago, but Mineware was a Mining3 company as well. So just to give you some examples of who we are. So what I want to do is quickly take you through why this is important. So if we think about what's going to drive our industry in the next 10 to 20 years. So the mining industry says to us, think about what you think the world will look like in the next 10 to 20 years, and then let's start working on how we get there. And so if we think about what the world will look like in the next 10 to 20 years, we find there are 3 key drivers. One of them is deposits. So we're changing the types of deposits we're finding, right? And so many of those big tier 1 type deposits that we're going to find near the surface are going to change, but there are many, many, many other very high grade, very good deposits, maybe not as big, that sit just below the surface or near the surface, or are in areas that where these deposits are near each other. And in the past, we might want to create very large mining complexes, but today we can't do that. We're going to have to respond to what those deposits look like, and we're not going to be finding tier 1 deposits, big deposits for the future. The next one is financial. If you know that the global mining industry is about 10% of the world's GDP, we only attract about 1% of the capital. Okay, so if you think about it, we attract between 1 and 2% of the total global capital for an industry that's about 10% of the GDP. So it tells us that we're not going to have money to build big mines, and we're going to have to be very particular about what that money does. The other things that's going to happen is that money's going to come with strings. You're not just going to be given $1 billion to return 10 billion. You're going to be given $1 billion to say, how are you engaging with the local community? How are you creating value that is sustainable? How are you environmentally friendly? How are you affecting climate change? So how we use money is going to be very different in the future. So the third one that we think is the driver that's going to change what we do today is that last one, sustainability. So that is about how we engage with community, how we engage with the environment, and this is what will change our industry very quickly. It's not whether we can make money, but whether we can do that with the communities, within the environment, within the social requirements of what the world is going to put on us, okay? And the recent failure in Brazil of a tailings dam is a beautiful example of that happening, and we're going to see that happening even further. And these are some of the things that the mining industry is telling us that we need to do. We have to have mines with lower footprints. They've got to be flexible. We've got to develop solutions to mining that happen quickly, okay? They've got to be cheap. We can't put in $1 billion or a $10 billion mine and then realize we made a mistake. We've got to put in a $500 million mine, understand and optimize all of the components from how we mine to environmental to social, and then scale. And we need to scale down when commodities drop off, and we need to be able to scale back up again. We can't do that with mines of today. And the reason is that we put all the intelligence in the process plant, okay? Mining itself is a very large transportation system where we say, we build a statistical model that says ore's there and waste there. It isn't actually there, it's there in a statistical model. We then send trucks and shovels to dig it up, and we move it to the process plant to put the intelligence in. We need to put intelligence in the mine, and that's what's going to change our world. Because if we can't do that, we won't be able to mine large deposits. So the question is, if I have a high-grade deposit and I take out 100% of that deposit, which creates a large hole in the ground, and then has a big processing plant with a tailings dam, is that more environmentally favorable than if I instead take 30% recovery over a much larger area with a much lower environmental footprint? In fact, we might create much, much different types of mines that will give us more commodity, more copper, more gold, more everything if we do that, because we're going to have many, many more deposits that we can mine. So we have to start rethinking what our world looks like. So here's I'm going to quickly talk about this because this is an evaluation of ore deposit complexity, but not just from a complexity point of view of how does mining, what we typically think of complexity in deposits today. We think of complexity in what's the grade, whether there's materials there that reduce recovery, etc. But thinking about complexity across all of the aspects, environmental, social, etc. And when we start looking at those and we evaluate the top 40 deposits, copper deposits in the world, we start seeing some very interesting information which tells us that 75% of the deposits that we have listed in that top 40 list have high risks associated with non-economic value. So what we're saying is that all of those, 75% of those deposits have risks which will stop them being mined or will make them difficult to be mined, which are associated with environmental, social, and other aspects that are not mining related. So even if that was a great deposit with high economic value, you may struggle to mine it, or you may have a lot of challenges associated with mining it, which has to do with environmental and social activities. So the question is, what do we do? Well, this is what I'm going to put these up, and I'm not going to cover them in detail, but really what we need to do is think about technologies that we have today that we've been talking about. Those technologies are the key to what we need to do in the future, but it's not about making stuff more productive and more profitable. It's about changing what we do, okay? It says our development and utilization of technologies must not only be focused on making mining today, we must use technologies in transforming minings in ways that allow us to operate in that new environment. And that new environment is one where we have a transparent and shared value proposition. So what we're saying is that we need to apply the building blocks that we see today, that we've been talking about, so that we can learn about where we need to go in the future. And so I'm just going to quickly go through some examples. Mining3 has a vision that has 3 pillars. One says, whatever we do, we need to have control, okay? We need to have precision and control. We need to bring precision as close to the face as possible. There are some very stark examples, and many mining companies around the world are working on this and understanding that the sooner we can make a decision to the face about the value of what's in front of us, the more money we make out of it, and we can fundamentally change the mining processes. So we need to make mining, and we need to create lean, what we call lean minerals production. In-place mining says we need to fundamentally think about mining in a different way. Okay, we are not going to be able to mine sustainably by saying to people, digging a big hole in the ground is a good thing to do, and we're going to create enough money to fix it up afterwards, because we're going to have lots of consequences in that 20, 30, 40, 50-year lifespan. So we have to fundamentally rethink what that looks like. And the last one is what we call sustainability through technology, which says we've got to build mines that are controllable, that we have precision and control over. We've got to fundamentally change those, and all of them have to fit into the requirements of what sustainability will put on us. Because it doesn't matter if we create a great mine with great economic returns, if the community won't allow us to mine there, we won't be able to do it. Okay, so if we use technology to just do what we're doing today, we will not get to where we need to be in the future. And the mining companies that are running mines today will not be the mining companies of the future. There will always be mining, but the companies that run it might change drastically. And you might say, well, that doesn't make sense. But you ask yourself, why did Amazon buy Google, would buy Whole Foods? Amazon's not a food company. They bought Whole Foods because they're a supply chain optimization company, right? And so mining is very similar, right? We're a supply chain optimization company. People with very different ideas might be running our industry in the very near future if we don't change. So, what do these things mean? And these slides are all available for you. So in this lean mineral production, these are all the types of things we want to be working on, okay? Automation, interoperability, etc. And one of the big projects we're working on at the moment is one being funded by Corfu in Chile around interoperability. It's called the Interop project. BHP and Codelco are the drivers for that, and it's really about how do we develop within the mining industry an understanding of how we create interoperability for the future. So it's not creating interoperability just for interoperability's sake, but it's how do we create value from that. So what Mining3 and CSIRO Chile has been doing as part of that is developing a conceptual model and framework that allows us to look at these problems and talk to the industry about where we can create value. If I go to a mining company and say, give me money for interoperability, they won't give me anything. But if I say, I can solve a problem for you, and by connecting things together that create value, then that will create opportunities for generating interoperability and standards where we can then create value and build the framework that we need. And so Mining3 in the Interop program has developed a framework based on Industry 4.0 that developed a conceptual model that thinks of the mining value chain and the interoper layers and domains in a way that tries to collect assets in the value chain through to the enterprise and the market. And as I said, we used an Industry 4.0 framework. We've had to change that framework of Industry 4.0 in order to turn it into something that's useful. Industry 4.0 is based on automated systems manufacturing. Mining uses lots of humans and other people in its activities, and so we have to change it. And so we've been looking at how do we solve problems in that framework. And it's interesting. When we look at the asset layer, we see a lot of connection of data. When we look at the enterprise layers at the top there, we see connection of data, but the real value in interoperability is connecting assets to the business. Okay, and these show us where are the right problems that we should be working on to create interoperability. Okay, what are some of the other projects we're working on? This is a project we're about to commercialize by the end of this year. It's a technology that allows us to find uncrushables, so unwanted materials in feed streams into crushers, and this allows us to look for uncrushables. We have this technology running at 4 sites around the world already, and we'll commercialize by the end of the year. And this allows us to find those unwanted components in a feed stream. This is another technology, allows us to get the trajectory of a percussion drill hole by putting a little device just behind the bit. When you drill that hole, in this case here we're showing a underground ring drill. when you drill that hole and you finish drilling that hole, it gives you the precise trajectory of that hole right away without having to put a survey tool in there, okay? Now, if you then connect that to systems that allow you to make measurements about what the rock properties are, it can tell you where the boundaries of your ore zones are. It can prevent dilution by blasting where you shouldn't, etc. And this technology is being commercialized by Robert. Robert has it working. This is a license that Mining3 provided to Robert for the technology. They've got it working in surface percussion drills, where we're getting that data given back to the operator and to the site right away, and we'll be testing the underground version of that in the next month or two, and will be available for the underground application. This is another technology. Here we go. Building the fundamental concepts of what we need in mining. We need technologies that allow us to get high densities of information in real time. If we can get feedback quickly, we reduce the complexities of the models we need to get complex operations done. This one shows a technology where we lay a fiber along the side of a conveyor belt. That fiber listens. It's like having a microphone every meter along that fiber. We can lay a 10-kilometer fiber, and we can listen to every idler. I can then take that data when I'm listening to the idler, and convert it into something where I can plot the failure of each individual idler, and we can detect the failure of individual bearings in 10 different failure modes, and we can tell you when that idler is going to fail. We have that system running in a number of mine sites around the world, and then we will have the first commercial units through a company called Future Fiber Technologies, the AVA group, and that'll be available to the mining industry within the next 2 months, by the middle of this financial year, or the middle of this calendar year. So these are all building blocks of technologies. This is a technology that allows us to get high density of data to feed back into mining that allows us to solve problems in different ways. So think about the world now where a mine has, instead of going with economies of scale, thinking about what's the material in front of me, then maybe instead of having 400-ton trucks, we want 20-ton trucks or 30-ton trucks. And if those 30-ton trucks are automated and electric and can be connected in intelligent ways, we can start thinking about how we take material out of the mine in a very different way. Because if I put 400 tons in a truck, I have to designate that 400 tons as ore and waste. If I have 20-ton trucks, I can mine selectively and use sensors at the face to tell me what is that material that I'm digging, and putting it into 20-ton trucks, and then connecting it in different types of mine transportation systems that look like this. So we've come up with a framework that shows you how we might think about mining in a different way. And this is really about coupling mining, discovery, mining and processing in a much tighter way, okay? Because it's very difficult for us to control processes in mining, because we create a block model, we designate that material, we then mine it at some point, we take it through some stockpiles, it goes through the process plant. It's very difficult to connect all that information. It's very difficult to connect all that information and optimize. But if I can discover, mine and process as close to the face as possible, I can create loops that allow us to optimize what I'm doing, and I then process far less material than I would if I moved it all to a large processing plant on the surface. And I can optimize the processing at each face that I mine. Okay, and so I won't go through a lot of these, but these are some of the concepts of doing that. This is what we call inline mining, which allow us to say, can we look at a face, identify the grade, cut that face selectively, and send it through different process streams, and start saying, well, an underground mine, instead of having a 5x5 tunnel and moving all of that material to the surface as high grade, what if I selectively mine it and decide what I send to the surface and what I process underground? I start changing fundamentally what a mine looks like. And we're showing these concepts here in underground because people understand them, and we don't have enough time to talk about surface, but we can do this, we can use the same kind of concepts for surface mining. And we're looking at doing that today on how do we do it for large-scale surface mines. So the surface coal industry in Australia has decided that a huge amount of their value is associated with the fact that they break rock with drill and blast systems, And then the optimization of all the systems that come after it is very much dependent on the characteristics of the broken rock that they break. If we break rock with rock breakage systems, with mechanical cutting, we control the size of the fragmentation and the productivity, and we can then fundamentally change what all of those systems look like. We also fundamentally change what a surface mine looks like. We can make mines much smaller. We can change fundamentally how we do that, and that's what we're looking at. How do we use these systems not to do what we can do today, but change the types of mines we have today? And that's what we need to be doing. Okay, we have most of the building blocks to doing it. We're working on lots of the gaps. We're just not brave enough to try them. Well, I'm going to say that in the next 10 to 15, 20 years, it's not about being brave enough. We're going to have to do it because the world's going to say we're going to have to do it. Otherwise, you won't be able to mine. Okay, here's another one that we're demonstrating some pilot plants on. And this is about saying, well, what if underground, instead of doing in-situ leaching where I drill a borehole and then leach between it, what if I build underground in-situ leaching facilities? What if I think about having leach pads but have them underground? I break the rock underground, I just bring the swell up, and everything else I process underground. Means that I fundamentally change what I do, but what it does do is say, well, if I look at something like this, where I'm looking at a satellite deposit next to a pit, it tells me that if I continued stripping the pit, this is what it would look like. I'd get 100% or close to 100% recovery. I'd have to put a lot of money into it, and I get an operating profit of that much. If I use this, where I'm getting 30% recovery, okay, I'm putting in a whole lot more money, and I get a very similar amount of profit. So my return on investment is very much better than doing this. And so the world says, well, maybe if I do this, instead of creating a large pit with a large hole in the ground and lots of tailings dams, what if I do this, where I don't have much surface footprint, I don't get as much recovery. Because I don't get as much recovery, my resource gets, and the costs are much lower, my resources get much bigger, but my return on investment is better, and it has a better engagement with the community, and I can change the business models by which I do mining. So these are some of the concepts that we're thinking about. And finally, this concept of sustainability through technology is one that's really becoming important these days, and you're seeing it through the population of mining companies in the ICMM, the International Council for Mining and Metallurgy. That has grown from 8 or 9 companies 5 or 6 years ago to 28 companies today, and it's because people are thinking about how do we engage with our communities, how do we turn mines into things that people want in their areas, right? And so we've got to think about mining in very different ways. We've got to think about how a mine is part of a community, how a mine becomes engaged in the local people who want to be part of that. How does it create value for them in many different ways? And so we're starting to think about how do we do that and building roadmaps for doing that. But really what it says is we can't just apply technology to do what we're doing today. We need to be applying technology to answer these questions and do things completely differently. And so we've got a lot more activities and a lot of stuff that we're working on at the moment, all of it being funded by the mining industry because they think this is really important and we think it's important. The technologies we've been talking about today, in all of the wireless technologies, the automation technologies, are all really, really important. In fact, they are the building blocks. We just have to think about them, not about how do I make the truck that I've got today go faster, but how do I change what it does or change the way I use that technology in a mine to do something completely different, because that's where we have to go. Because we're not going to survive by just making stuff bigger and faster. Thank you.
Thank you, Professor Lever, to share with us your vision of our mining sector. I'm sure you have some questions.
I'll answer them
please.
later.
Could you choose 2, please? Thank you.
Yeah, so the first one, would you suggest you move from perception of added value to projects leveraging? And so that's about building models and understanding the value You can't just do this by saying, well, look, you have to go there because it's great and we think it's great. You have to build models that define exactly what the value and how the value that's created in the mines of today, and then how do we build models that say, if we apply these technologies or we go to these new concepts, what value do they bring? Now, the important thing we have to do in that is we have to quantify what's the value of social, environmental, and other aspects of mining, right? So if for me, the difference is that I can move to a new mining concept, but the local community won't allow me to get a permit or won't allow me to mine, then that has no value at all. Okay, we have to connect into all these value models, how we value sustainability and how we connect that into the models of the future.
Great. Thank you very much, Professor. Un aplauso para nuestro distinguido participante. Thank you.